How's it going, Misha?
It's good.
It's good. We're in Istanbul
Uh,
today. I think it looks like Istanbul. I'm not
yeah.
sure.
Looks like it.
Yeah, I know people in the camera can't see, but we are sitting in front of what I like to think is the nicest view in
Yeah.
Istanbul. Maybe it's
Yeah.
not bad. Is this your first time in Istanbul, or
Nah. I mean, been here several times.
been here a
Three
few
times,
times?
I guess.
That's cool. We're here for Bitcoin Plus Plus, and we were just talking about how you're here giving a research update on a project you've been working on for how long now?
I guess it's. I mean, officially since October last year, I would say. So it's
Cool.
like it's been a year and a half, I guess.
Okay,
Yeah. So it's kind of that.
so about a year.
Yeah.
What's the project that you're working on?
Yeah. So what's going on our side is basically we're trying to figure out the way to define covenants and to verify ZKPs on Bitcoin without any soft fork or
No
like without any
software.
changes. Yeah, no soft fork. Like we're not getting it. Relax. It's like arguing about the soft fork is pointless. So we're trying to figure out the way, and we call this way Bitcoin pipes.
Pipes. Okay.
Yeah, effectively, and like it's again, like it's an attempt to apply like a Fustopia level cryptography to induce conditional decryption of a key or of a signature to indicate the correct verification or the correct execution of certain computation off chain from Bitcoin non-interactively.
Okay, so you're moving the computation off chain.
Yes.
What is so right now computation is kind of on chain when you run a script, right?
Yes.
And every node that gets a transaction that has
Yep.
a script in it executes the script. Using Bitcoin pipes, you're going to try and add more opcodes, is my understanding. So expand the range of what's possible to compute using a Bitcoin script, but you're going to make the computation happen not on everyone's
Yes.
computers. Where is the computation happening then?
So basically, the computation can happen on anybody on anybody who's willing to prove that certain computation was done.
Okay.
So like it's probably it's gonna be like on the user side or like on the specialized whatever like dedicated hardware user can outsource the computation to or
Okay.
something. So I mean yeah, that's what it is basically.
Is this okay? Is this client side validation? Is this in like the realm of client side validation or
No,
like
no.
no?
No.
Okay,
Client-side validation, in mostly is about attesting that certain state happened on the user side. So you're like after that you're submitting some Merkle roots or something like hashes, so a person can verify that and that they're working with the correct data and things like this. In here, it's more about and like also, sure, it requires like everybody to have a consensus around the software you're validating the data with. So it's kind of implicit consensus you're having. And again, it's kind of the control over the repository again decides everything, the fate of everything. So that's a little bit of a nuance. In here, like we're not talking about like a client-side validation. We're talking about more like I mean, well, more like more like an attempt. Okay, well, there is no specific requirement for this to be done like on the client side or something. Like it can like whatever it probably will be like done on like a wallet side or like a front end application side or something. It's yeah. So like Bitcoin pipes also do not require this implicit consensus of like software which kind of downloads the data and like renders the state or something else, and it also doesn't require any interaction between who attests the correctness of a computation. It's kind of supposed to be non-interactive.
cool.
So it's pretty far from client-side validation in terms of what does it get you and what does it imply.
That's cool. So like you've been working on this for almost a year
Yeah.
now, and you just gave a research update, which I'm really excited to go watch the recording for when we get back to Texas. But can you give us maybe like a short version of like what the update is, if that
Okay.
makes sense?
Okay.
Like,
The initial idea, the initial kind of whatever construction, and the end game construction, I would say, of pipes themselves, is that you can define a circuit, you can kind of encrypt some key collectively, probably, but with some MPC or something. You can give this ciphertext to like a user or like to an application, And you can make the user or like an application to perform certain computation, for example, concatenation or multiplication or something else, some missing opcode computation or like missing piece of opcode computation. And then basically get a user or a front-end application to compute either a signature of a certain transaction which is supposed to continue with the execution of certain application, or to decrypt a key which will attest the successful application of this particular ZKP thing. And because this happens entirely on like the application, on like user side or something else, it doesn't require anybody to talk with anybody to talk with each other. It's kind of a non-interactive process. So that's the end game, how it should work. The current research update is like this kind of construction, non-interactivity, requires to have a functional primitive, like which is kind of a Pustopia level primitive, like functional encryption or witness encryption,
Cool.
which is still pretty, kind of still an open problem. And sure, there are a lot of like special purpose witness encryption schemes. There are a lot of like special purpose functional encryption schemes, but like none of them fit this purpose. So the research update was primarily about how do we go after this functional encryption / witness encryption scheme, which would fit the purpose. And it's kind of a little bit of a dive into the life of people who do obscure cryptography.
Okay. So your research work consists of reading the literature, talking to people, or are you actually like building like toy protocols or primitives? Okay.
Toy
Cool.
protocols building, trying to understand what security properties they induce, which performance properties they induce, which properties from the user experience perspective they induce. For example, there was like a prototype protocol on our side which and it still kind of is, it's still an option. That's what we effectively called pipes v1, is when we try to induce the conditional decryption, like witness encryption from QFE, from quadratic functional encryption, and then we're like, oh, it might be not really secure, but like, can we make it secure enough? And
Got it.
it was like there was this whole idea that it still kind of is. There was this whole idea that we could probably just, even the smallest gap between like the honest evaluation of the scheme and the malicious evaluation of the scheme, we could amplify it with the size of a witness, like to the point when the malicious execution of the scheme becomes impractical. But like when
Got
honest
it.
evaluation is still practical.
Got it.
So
That's interesting. Okay.
yeah. So this kind of stuff, like here we play with assumptions, we play with what the user needs, what's the cost people are ready to eat, and like what's the.
So are there any costs for clients? Like, so I know like for DLCs, are you familiar with DLCs?
Absolutely.
Okay, yeah. So one of the things is like the setup cost is quite high, right? There's like a certain amount of time it takes to compute all of the signatures that you have to sign or whatever, and then there's a space requirement of what you have to save in order to have a DLC contract. What are the costs, I guess, of using these pipe scripts?
Okay.
Is it a script or is that the right word?
Just pipe. Let's
Okay,
call it
pipe.
just pipes.
Just pipes,
Like
okay.
pipe script is a separate thing. We'll come to that.
Okay.
Maybe next year, I guess, but whatever. Pipes effectively induce costs, specifically pipes v1 induce quite large costs in terms of what it gets to decrypt the key or decrypt the signature. Again, basically because that's the assumption of the scheme itself when you're like kind of inducing the security from like this gap. So this kind of stuff. It basically, this computational complexity is why such a witness encryption scheme is possible. Like at least theoretically it's possible. So that's what it is. In terms of like, can we make it cheaper? Can we make it more interesting? Can we make it like executable on the client side, on the phone, on like laptop? That's effectively why we started working on what we call pipes v2.
Okay.
Which is supposed to be a little bit less obscure. It's supposed to have more classic security definition with like, hey, the attack cost should be exponential ideally, and like the execution should be as cheap as possible.
Got
So
it.
it's kind of like a push towards two directions to make it more compliant with what people traditionally assume when they talk about cryptography.
Got it. Okay. And sorry if I missed it, but like if a client is trying to use a pipe, are they going to have like a CPU cost to do the decryption?
Yes,
Okay.
yes, it's basically a CPU cost.
Got it.
We do
Okay.
not expect actually people to use it for like a single opcode or something. You can for sure, you sure can do that, absolutely. But it's just a
Okay.
little bit too expensive, okay? So we expect people like in the majority of use cases to be induced from like the usage, for example, like ZK rollups.
Yeah.
Like this is how true ZK rollups become possible.
Oh,
Like you
okay.
basically can like just you can do the state transition verification within the ZKP, a single transaction, pessimistic state transition verification. No optimistic games, no like whatever.
Right.
Yeah, like no interactivity or something. Shove the transaction into the mempool. It's verified. That's it. You can't undo that.
That's
So
cool.
that's what it is. And
So it would solve kind of all this like sort of the security trade-off assumptions that they're having to make with the BitVM construction right now.
basically,
That's cool.
basically.
Okay. At the cost of making the client have to do a lot of computation.
Uh, yes, yes. The CPU cost is the downside of this. But again, like we're working on the V2.
Yeah,
It's not done
okay.
yet.
Can you quantify kind of what level the cost is? Like, is it something that someone with a phone could do, or is it like you need like a GPU? Does it have
You'd
like a
need
dollar value?
you'd need a
Like,
bunch of commercially available servers.
interesting. Okay, so that is quite high. But
Yeah.
you were saying it's not like client-side validation where each client is responsible for doing the validation themselves. This is like you can almost like farm it out to someone else to do the verification for you.
Basically.
And once someone's done the verification, is it then it becomes widely available for everyone to
Yeah, once
use, if that makes sense? Or,
once somebody's done the verification,
or the
key,
decryption,
yeah,
maybe?
the key is basically decrypted. The key becomes available.
Okay.
So like this key, whatever the transaction is being done with this key or like with the signature, can be effectively an attestation of the fact that the successful ZKB verification has happened. So basically, anybody can sign it or anybody can do anything. And it's not harmful to like even like write this private key on like whatever, like on the wall.
Right.
And sure, please do the transaction for me. Don't want to pay the fees.
Right, got it. Yeah. But basically, you need someone to invest in doing the work to decrypt the private key.
A little bit, yes.
Yeah. But once that happens, it does, like, the keys can be made widely available. It's
Absolutely.
not like a thing. Okay. Cool. And anyone, of course, can invest in decrypting it. Got it. That's cool. Do you have like yeah, that is a question. So assuming you had access to like, I don't know, these servers, do you have any estimate of like what a cost would be for it? Abdul had a talk earlier where he was like, it was like $13 to sync the chain using ZK stuff. Do you have a similar number that you've
Oh,
computed or like,
yeah, like we've had some estimations of this for the like witness encryption induced from QFE. Again, this is like security assumptions of that. Again, disclaimer, are not the best ones.
okay.
We're working on fixing them, but there was like an estimation of that. In the end of the day, we estimated effectively how much of Bitcoin can you store behind a single pipe, like behind a single pipe of a version 1.
Okay.
And we resulted in like that you can store maybe like I don't know 1/100th of a Bitcoin, like 1%, like whatever.
So it would be, I think 100,000 sats.
Basically,
Yeah.
basically, like at
Okay.
most with the current prices.
But you
with the
said
current
1/100th or
1/100th.
100?
One divided by 100.
I think that's 1 million sats because there's 100 million satoshis in a
Okay,
Bitcoin. Anyway,
So
sorry,
like
yeah.
basically the
million
assumption
sats.
was made. Basically the assumption for that estimation was made from the fact that you got to make it impractical for the attacker
Okay.
to try to even mess with this. And like we got to make it just cheaper to mine Bitcoin than this, because I mean, again, like imagine somebody tried to attack this.
Okay.
Will they succeed? Sure, they will. We know they will because the attack complexity for V1 was supposed to be polynomial.
Okay.
And we know that they will succeed. Sure. What they will get? They will get something like they've spent, they will get something which is worth less, like 1,000 times than they've spent on computing this, like the
Got it.
decryption. So like, what's the point?
Right.
And sure, maybe you can do that just for the sake of messing with the protocol. Absolutely.
It's
But
an economic security, so to speak.
basically, that was
Yeah.
supposed to be the thing for V1. Again,
Okay.
For V2, it's going to be proper.
Okay, so economic security is basically it's more expensive to do the
Yeah.
computation than the amount of
Yeah.
value you can
Yeah.
expect if the
Yeah.
computation's
Yeah.
successful. what is proper security? If economic security is not proper, what is property? Just that you're not even able to do the calculation.
Yeah, like
Got
proper
it.
security is exponential attack cost. You will not have enough of compute in the universe to like
To do it, which is similar to Bitcoin private keys, right? Yeah.
So it's gonna be basically the same.
Cool. That's very cool. So you just gave a research update on what's going on. What's new? What's next? So you're continuing work. Like you kind of mentioned that maybe there would be a script for it at some point in the future, but not currently.
Yeah, there is like since pipes effectively induce since pipes effectively can induce the extension of script with like necessary opcodes. This kind of extends the script itself. And this gets you to what you can call like, we had miniscript, we had script, we had tap script, and you have pipe script.
Pipe
With like
script.
an extended set of opcodes you can use or
C++
like
almost. No, I'm sorry.
kind of that.
For those of you who aren't aware what the difference is, C++ is supposed to be like an extended set of C, right?
Yeah.
Like, yeah.
So it's kind of that like pipe
Okay.
script. So when you have jumps, when you have like where
Script
you
plus
have
plus, sorry.
yeah, script plus like where you have jumps, where you have like multiplications, where you have like cap or anything else you want and it's not harmful.
Got it. Yeah. Cool. I'm trying to think if there's any. So if people are interested in learning more, or maybe are you looking for contributors? Like, is there ways people can get involved in it or learn more about your research and what you're working on? Where would you send people? I guess or.
Well, I mean, at this point, it's just we're publishing stuff on the website, and like then the Twitter is just sitting there. So, I mean, that's kind of that.
Okay.
We have a little chat like set up for like public involvement, but again, we're trying to be careful because it's easy to hype people up for witness encryption, but when you're like, you gotta actually do the thing before you hype people up.
I
You
see.
gotta provide people with like the actual security before
Got
you hype
it.
people
Okay,
up.
yeah. You said there's a chat. Is that on Discord? Is that on Telegram?
Just Telegram, like
It's on Telegram. Yeah, I was talking to Robin earlier, and he was joking that everyone thinks on Telegram these days.
yeah.
It sounds like you guys are no exception to that. Cool. I'll see if I can find the link and put it in the show notes
Okay.
so people
I'll get you that.
who are interested. And then for witness encryption, that's like a new term that I'm not familiar with. I'm sure many Bitcoiners probably aren't very familiar with it either. Is there like a place that people can learn more about it, or like what's the best way to get into the witness encryption rabbit hole if someone's interested in learning more about that?
Honestly speaking, it all starts with Gark and Denbene papers.
Okay. All right. Yeah.
So it's that.
Dan Bonet papers. Gark. What's Gark? Is Gark a protocol or
No, Gark is one of the inventors. So
one of the inventors? Okay. It sounds a lot like you could like see how that's
or
like
like
a Stark
Brent
thing.
Wars and this kind of people.
what?
They did a lot of good. They did a lot of good paper on that. They did a lot of good papers on that.
Cool.
So.
He didn't name something after himself. Gark. No.
No, they did not. They did not. I mean, Rachel Lynn, or like recently I saw people popping up here and there with like doing interviews with Rachel Lynn about I/O and things. So she's also one of the godfathers of this. So,
Okay. Cool.
so,
Maybe we can get her to the next
Actual.
conference or event.
Actual.
So you're here in Istanbul this week. Are you going to go to any other events while you're here? Or are you? What's next on your conference schedule? Is there somewhere people can see you talk next?
Honestly speaking, it's the primary thing I came by in here. I mean, basically because that's the primary thing we're like occupied with. Like this, just give people a sense about like what's going on, because it's been some time.
Yeah,
And,
definitely. Cool. Well, we're really glad you're here and hope to see you at another event sometime soon
Yeah.
or hear an update on pipes or maybe a
Yeah.
launch announcement.
Yeah.
Oh, what did you call it? A splash?
splash. A
Yeah.
splash.
When you got a splash to make.
Splash.
So cool. Thank you, Misha.
Yeah, right.